Thank you all for joining. This next session features Infinite Lambda. I'm excited to introduce Nas Radev, co-founder at Infinite Lambda. Nas has spent over 10 years as a data and BI engineer prior to co-founding Infinite Lambda in 2019. At Infinite Lambda, he and his team of 90 consultants have designed and implemented nearly 30 modern data platforms for clients globally. Nas's passion lies in enabling organizations to be better through data. His talk will detail top reasons for building a modern data stack, what makes something modern cloud-based, and most importantly, how not to fail in adopting a modern data stack. So, a warm welcome to Nas.
Thank you, Alexa. Many thanks for the kind introduction. And hi, everyone. Very, very happy to be here today with you. I'm going to share some insights from our work here at Infinite Lambda, where we spent most of the last 2 years really building these modern data stacks for businesses across 14 different industries. And just a bit about our company. So Infinite Lambda is a data consultancy. We consist of around 90 people, mainly a majority of us being data architects, cloud and data engineers, analytics engineers, and a few data scientists. And in terms of areas that we cover, our biggest areas really are fintech, e-commerce, edtech, gaming, and biotech. But across all these 14 industries that I mentioned, what we tend to really specialize in is building these modern data stacks from scratch, from the ground up. And today, I wanted to share some insights around the why, the how, and the how not to build a modern data stack. So this is the agenda for my brief talk. I'll cover the reasons why some of our clients want to build a modern data stack in the first place. I'll talk about what exactly makes it so modern. Then I'll deep dive into what you can expect your modern data stack to look like. I'll go through the steps of actually building it, and then I'll go through the missteps that you should avoid. And rather than keeping the use case at the end, I'll actually try and use it as I go along to try and illustrate some of these points. So let's dive in. Here are the top 4 reasons based on our last 25 small to medium-sized clients. Obviously, this is more anecdotal. It's not a proper survey. It's just our clients and it's just one consultancy. But I thought it's worth sharing because 25 is a decent enough number. So let's dive into those. Concretely, we've got 28% outgrowing their manual reporting. Obviously, there are some very standard reasons here, such as your business reports are manually generated, the data is pulled manually, then it's manually cleaned up, and it's transformed in Excel, which takes a lot of time. You can make a lot of errors in the process, and it usually blocks a few key people spending a lot of time on this thing, and obviously it doesn't really scale. Then we've got 24% who said that the modern data stack is very useful for better integrating data from multiple tools. So what I mean here is, if you think how a modern business really functions, they probably use a bunch of third-party tools like Salesforce and Shopify and Facebook ads and so on. And where most of these tools are used, they'll probably also be storing lots of your data, especially lots of your very, very valuable, useful data for all sorts of analytics. And to answer questions like, who are my most highly valued customers and where do they come from and why do they churn? It's not really always trivial. You have to pull the data from all these different tools and then integrate it. And it turns out the modern data stack is very good at doing just that, and then making the data available for analytics quite quickly as well. So the next 16% told us that they mainly suffered a high cost of their existing analytics platform. So what that usually means, I think, is they already had some more traditional data stack that they had to effectively keep a small army of engineers just to maintain. Or they maybe had a modern tool, but that was more of a tool that they started with when they were very young as a company. And then as they grew, the tool also grew with them, but so did the cost. And it is with some tools, it can grow exponentially. So they were looking to move away from that. And then lastly, 32% wanted to reduce engineering time and cost. And they probably already had again, a traditional data stack, but the cost of building new pipelines and integrating data, and then building reports and helping with ad hoc analytics was just too high and took too long, and also it was really blocking the business. So they were looking to migrate to something more modern. So what makes the modern data stack so modern? I really like this question. I love it when people ask me. Well, firstly, I would say it's cloud-based, which brings a bunch of benefits like the ability to scale out of the box without having to do anything really or very little. Secondly, it's very easy to get started with. So you don't need to wait for servers or long installations or updates or setups or contract negotiations for things like support and SLAs and other things like that, because there's often very little or even no maintenance when it comes to some of these tools because they're software as a service. And depending on the tools that you choose to use, you might actually end up needing much smaller data teams. So what I mean here is, in the traditional data stack, you would need folks like ETL developers and DBAs and other folks who I will talk about in a minute. But in the modern data stack, really, you don't really need as many people, and you actually only need 2 roles that I will discuss again in 1 minute. But I think that's a major advantage to the modern data stack, just how lean your team can be. And of course, this is because you get a lot of stuff out of the box. Many of the things you would need humans to build, you just get for free, or well, not for free, but comes with a tool. The last point worth mentioning is that these tools are not really just sporadic, detached tools that just form up a concept of a modern data stack. In fact, they really form more of an ecosystem. And what I mean by that is, it's very likely that your modern ingestion tool is going to work really well with a modern cloud data warehouse, which in turn is going to lend itself really well to a modern BI tool. Because really what happened is they all got started together, they evolved together. So they're kind of like a group of close friends for the last 5 years or even more. Many of these tools that have come to existence have really just been building on one another, and that's why they're currently so strong together. So let's talk about what the modern data stack architecture looks like, specifically when the typical design architecture, when you kind of put it on at a high level like this, it's useful to think about it. And traditionally in data, we've thought about data as flowing, I guess, from left to right, whereby on the left you have a bunch of data sources. Again, in the modern business, usually many of these data sources will be third-party tools like your Shopify's, your Facebook's, your Klaviyo's, etc. There's hundreds of them that are super useful. And maybe you have some first-party tools as well, even things like spreadsheets or your own databases. And so really what the data stack, the modern data stack deals primarily with is the ingestion of this data into a centralized place, and then how this data can be utilized for reporting and analytics and all sorts of useful stuff across the business. To do that, we really need a modern ingestion tool that can integrate well with these third-party tools. And of course, we need a data warehouse and data lake, and we need a business intelligence tool to help us do the reports and gain the insights. But one thing that has come for us to take for granted is that you need both a data lake and a data warehouse. The lake here serves a very important function because it will store your data, including how that data changes over time. So many of the third-party tools may not care about history. They don't care about things like when an order address changed or how long it took for an order to get from a status pending to a status shipped. They just care about what's the latest status. And there's hundreds of use cases that are actually very valuable for the business when you want to start to analyze and understand how your business functions, and where's the bottlenecks and where you can optimize things. So the data lake helps you with that because it helps you keep history. It keeps all the data, regardless of whether you're going to actually need it right now or not. So it's best to keep all your data in your data lake. It's fairly cheap usually. And then the data warehouse is where you take that a step further. Data warehouse really makes the data easy for interpretation. That's the main purpose of it. It helps us to integrate data. It helps us to build convenience layers on top of the data for various reporting and analytics, but it's all about making it easy to work with. And so, for example, if you want to join your marketing data with your subscription data, with your stock data, if you're in e-commerce, then if you want to say, hey, if I run this campaign, how much more stock of this particular type of items am I going to need in 4 weeks or 6 weeks? And that's where the data integration comes. And I think that's a very, very powerful insight to have. And then finally, the BI tools, they have become increasingly powerful. They allow us to define a bunch of integration logic directly in the tool. And also obviously do a lot of exploratory analytics, a lot of standardized reporting, and so on and so forth. But as it turns out, data can get quite complicated, especially in modern businesses, and whether they're small, medium-sized. If you use all these different sources on the left, you might even end up having more than 10 different tools that you have to pull data from, which requires a lot of business logic just to describe how to join up all this data. And oftentimes, especially when you throw in some spreadsheets in the mix, there's a lot of weird stuff happening with each data set. So that obviously necessitates some manual, or rather, in the case of modern data stack, automated cleaning and pre-processing. And that's where the data transformation tool comes into play. And as your use of data matures and you need to link more and more of it to build a more holistic view across the business, this is where you need to put more and more logic into the so-called transformation step in the middle. That sits usually on top of the data warehouse. And this is where you have to do stuff like Kimball data modeling or Data Vault data modeling and other things like that, just to make sure you properly represent the real world with your data model. And really, the interesting piece here on this slide is on the right, where you've got you kind of have a paradigm shift here. Traditionally, we would think of using data stacks to understand our business, to analyze what's going on, to create some automated reports. But how does that actually help us drive the business forward? Well, it turns out when you have so much time to actually focus on the data and not on bringing in the data or cleaning the data, but to actually focus on analyzing the data, you come up with other things you can do with it. So now suddenly your whole data stack becomes not just for analysis, it's not just the brain, but it's also the muscles, because it can do stuff. It can help you identify the segments of customers that are the highest lifetime value for you, for example, the most valuable customers, and then say, take this segment and push it back into Facebook ads and tell the engine to, please engine, help me find more customers like this because they bring me a lot of money. And these are really the kind of things that your modern data stack allows you to do. It allows you to not just understand the business, but control the business, which is an immensely powerful thing to do, I think. Another evolution, and I would say this is probably where the modern data stack is at right now, within most of our clients anyway, is that as you grow, as you mature as a company, you now need to start worrying more and more about data quality and data governance. I will cover this in a little bit in my talk, but the surest way to fail a data project is to not be obsessive about data quality. So that's why a lot of tools have come into the market now that help you address that problem, that help you put data quality at the heart of every step of crunching data, analyzing data, reporting data, and so on. And similarly, data governance. You need to know who's responsible for what KPIs, what business definitions, who's using what data in what way, because that's how you can avoid having effectively a bowl of spaghetti within your business when it comes to data. And so I'll talk about this later again, but the data quality here really is an important piece to highlight. And then it's also interesting to mention that more and more automation tools are coming into this space now that help you do things like machine learning and data science by just plugging in some of your data from your modern data stack. Similarly, also to how you can create some segmentation, for example, in your analytics tool, you can then push that over to a data science tool and say, hey, do some forecasting or do some recommendations based on that. So let's talk about the roles that you need in order to actually build a modern data stack. And in fact, before we talk about the modern data stack, let's talk about the traditional data stack. The evolution I guess, of the modern data stack, really, I wouldn't say made these roles obsolete, but it sort of merged them into one and made sure that we no longer need to fight for very hard to find engineers, at least not as much as before. It made it much more convenient and much more easy to do some of these functions that some of these folks would traditionally do. So for example, the ETL developers, traditionally this would be people who specialize in things like informatica, talent, and so on. They would build pipelines that grab your data, transform it, and then put it in some structure that gets loaded into your data warehouse. And then they have to do a bunch of other stuff like code in Java sometimes, or fight with your data warehouse to make sure that that the processes don't break all the time. But really, what they end up being is the prime candidates for a bottleneck in the technology side of your organization. So anytime you need to make any change to your data structure, or you need to bring in a new data source, or you need to bring in a new field because you forgot to ask for it in the first instance, that always ends up being a ticket on a very long backlog on the Jira board for these guys. And by the way, ETL developers live a very hard life. I used to be one for a few years. I know the struggle. I can complain about it for many hours if you have time after. But really what they've been enabled to do now is to do other things downstream. Once the data has been ingested by a modern ingestion tool, now they can focus on actually making that data work for the business. Similarly with DBAs, we used to need at least one, maybe two, maybe more DBAs, depending on how big your data warehouse is, just to keep it alive. The modern data warehouses kind of keep themselves alive. It's all automatic. It all comes as a service, which obviously makes it much easier. Data architecture and modeling, this is actually still a very useful skill to have. It's more and more kind of internalized by the analytics engineers, which I'll talk about in a second. But they're really the folks who make sure that your data is structured in a way that makes sense for the business and that represents the business in a good way. And so finally, obviously the business intelligence engineers, they're the folks who traditionally mainly do business analysis and then create dashboards in a BI tool and work on some ad hoc questions. And they would be the only people who can actually build anything in the BI tool. So it wasn't a very democratic process. You'd always need a BI engineer to do anything. So let's talk about how the modern data stack changed that. Obviously, we now only have two roles that we tend to talk about a lot. One is the analytics engineer, who's kind of the new unicorn, but actually it's easy for people to get into analytics engineering so long as they have a bit of SQL knowledge and they have business analysis skills. They can pick up data modeling, they can pick up all the BI tools, they're fairly easy to work with. But the analytics engineer is really supported by these modern data stack tools that take care of all the ingestion by just a click of a button, or deploy a new database with, again, another click of another button, and so on. And when things get really tough and you need to deal with, for example, really big data or streaming data, that's where the data engineers come into play. So they need to know a little bit more about software development, about things like Python and Spark and so on. But if you are a small organization, you probably don't need one. If you're a medium one, then it depends on your use cases. So let's talk about, finally, building this thing, building a modern data stack. And perhaps, obviously, we need a use case. That's where we start. In our case, I'm going to talk about one of our clients. I really like their story. I like what they do because they're Outbox. They deal with rescuing fruits and vegetables. So they literally go to farms. They buy the fruits and vegetables that they think will not sell, so would be food waste. They put them in a box and then they ship them to the subscribers. And as you can imagine, over the last 12 months, they've grown quite a lot. And as a result, very, very classic scenario, they outgrew their manual reporting. They were struggling to do the data analysis to help them understand how their business is doing and why people are staying, why people are churning, what people like, what they don't like. There was a lot of manual reporting going on, but it was just becoming really, really difficult to work with all this data. So keeping that in mind, and actually one of the use cases we started with was churn. So let's understand when people churn, why they churn, and try and understand how we can stop it. So once you know what's your data, what's your use case, you need to understand where's the data that will support that use case, so that you can create some solution to the particular use case. And in this case, you kind of need to start with what exactly it is that you're trying to calculate and measure. You know, what is churn? How do we calculate it? How do we want to report it, etc. And then once we know that, we can start to identify where is the data. So in this case, it could be e-commerce data, so the orders and the user profiles, stock data, so what actually went into the orders, customer complaint data to see who then complained about certain things maybe before they churned, and maybe even marketing data to see what kind of campaigns they came from or what kind of vouchers they used to join, to understand what's actually viable and what isn't. And then things like how frequently to refresh it, if you're doing real-time actions or not, or the type of problems with the data, such as you might be missing some data, you might have data gaps, or data might be, you might have changed the system halfway through, so you might have two e-commerce systems, you have to connect to both of them. You have to sort of understand all these challenges and factor them into the decision-making process. But once you've identified the data sources, now is when the fun starts. Now you have to start building the actual modern data stack. You have to pick a tool. Obviously, you should have a list of the sources you want to connect to, and then pick a tool that actually is able to connect with them out of the box. That's always the easiest. And then the other question is, again, if you want to sometimes work with data more frequently, such as real time, that might change it. If you want to just be okay with a few times a day, then that's a different breed of tools again. Reliability, sometimes tools will use kind of open source packages or community modules that connect to many third-party tools, but they're maybe less reliable because who's actually looking after them. But usually these tools are cheaper, whereas other tools are obviously more expensive, but they're a bit more premium because they look after all these connectors. So obviously cost is a big consideration here. And then some of these tools actually do transformation. Some of them do not, but here usually you need to ask yourself, does my team know about SQL? Do they know about Python or Spark or anything that might help me do these transformations in a more democratic way? So again, I don't have just one or two people doing all the transformations being the bottleneck. Usually SQL is a very easy to learn tool. So I would pick a transformation tool that allows you to do as much as possible in SQL and then collaborate. So once we have ingestion, we have to store the data somewhere. Just quickly here, because I'm conscious of the time, when you're picking a cloud data warehouse, you always have to consider things like, am I already within my organization on a particular cloud vendor? That might really narrow it down. Or if not, do I care to look at some of the more agnostic tools? Like, for example, today we have sponsors AWS and GCP and Snowflake, and they all have tremendous solutions in this space. Sometimes they will have some more functions around cost control, special needs like data sharing, and so on and so forth. But usually, if you have an internal technical team, make sure you consult with them, because it's good to have a cohesive tech strategy as opposed to picking a tool because it has the most features. And then we have ingestion, we have storage. So now is when we start to identify again the KPIs that we wanted to calculate. We've defined how to calculate these KPIs. We've extracted the data, we've put it in the data lake, we've maybe transformed it to go into the data warehouse. And now we're finally able to start doing some reporting on top of it. And by the way, this will be a cycle that goes over and over and over again. To actually analyze it, it's good to have a BI tool. This is where there's a few very popular ones these days. I would say consider, is it easy to use in the beginning for the type of business users that you have, versus is it easy to scale once you have many more business users? That's always a good question, because some tools are much better in terms of user friendliness, but other tools will be much better at scaling. So that's maybe the main question to pick out of these here decision criteria. And then hopefully you have solved the problem and you have now iterated, you've completed one iteration. Now you have started to get the hang of this and you're ready to start pulling more data. So I'll skip through this slide because there's a lot, but I just wanted to indicate that in 2 to 3, even 4 months, you can do a lot, from box standard reporting through to more advanced analytics, churn prediction, then setting up all sorts of alerts to say, hey, when something extraordinary starts happening, alert these people so they can call someone and fix it. You can improve your customer support by integrating some of these insights with customer support tools. You can even start pushing stuff to machine learning tools to get some recommendations and forecasting. So quickly, in 2 minutes, I'll try and give you some insights that maybe I have learned over the last 2 years. So maybe the Q&A section after that will help me go into more detail, or perhaps even after the conference. But here goes the most important thing I'm going to say today. If you don't obsess about data quality, you will fail. Unfortunately, the main projects that I have seen fail have failed not because they didn't have the right people, not because they didn't have the right clarity of what they wanted to achieve, but they failed because they delivered something that was not accurate. And if you cannot trust your data when you look at the report, you're really not going to get traction in the business. And getting that trust is gold. If you can get trust, and if people can start being more data driven in the day-to-day decision making, that's when you have succeeded. If they don't, because they don't trust your data, then that's when you failed. So we implemented quality checks right after, with every single project, right after we ingest some data, right after we transform some data, there is a lot of checks to make sure, is the data correct? Does it look like what we expect it to look like? Also, when we transform it and we make it ready for reporting, we again validate. And before we share with customers, we always make sure that it's appropriate to share. The other thing is sometimes tools will enable you to scale very, rather not scale, but to get some traction very quickly, which is amazing. But then you will do so much in the tool itself, it will kind of become a ball of spaghetti very quickly, so it won't be able to scale. So that's why it's good to have a balance. Do some stuff in the tool, the BI tool I'm referring to, and then push it back to the transformation tool. So it's actually solidified in your data warehouse. It's a validated and tested process that everyone can benefit from. And then again, move some stuff into the BI tool, innovate, explore quickly, and move it back to the data warehouse. Just quickly, back to my previous point on data quality, if you're working in an agile way, that's great, but also don't share insights too quickly. Always go the extra mile, validate them, and then only once you are absolutely certain you're not going to upset anyone by giving them really bad data, only then should you actually promote things into a production environment. And maybe finally, or maybe not finally, but when people are used to going to tools like Shopify and Google Ads and other things to get their reporting, whatever you build with a modern data stack in terms of a reporting functionality, it has to be at least as good. So I would say in the first few phases, make sure that you can replicate what the third-party tools are giving you in terms of numbers, and then you can build upon that, because that's when you know at least you've hit the benchmark and now you can improve. We've seen far too often that people don't trust the BI tool because of the bad data problem, and they end up going back to the third-party tools. And finally, remember to have fun, because once you have enabled more and more people in the business to be data-driven and to have access to lots of insights, that's really when you know that they will, their jobs will change, and they will start having a lot more fun. They'll start just having a whole new dimension to what they can do in the business, which is really empowering. Great. My name is Nas Radev. Really happy to have shared these few slides with you, and I hope you enjoy the presentation.
Thank you so much, Nas. Based on the comments from everyone listening, I think it was one of the more useful sessions around data. We do have two questions. So the first question from the comments is there a need for a data lake if all data is structured and cloud data warehouse is already available? And maybe to build on top of this, when would someone use a data lake over a data warehouse?
Great question. I think they're also fairly conceptual as concepts these days. The same technology can be used to both be your data lake and your data warehouse. The separation is really in how you think about your data. Data lakes are okay to be unstructured. They're okay to be just a history. And then you would only use it to see what else is out there, what other type of data can I pull into the data warehouse, and maybe some data scientists who also really enjoy going into the raw data. If the data is already structured, that's fine. I think you can also consider data before it's been integrated and modeled to kind of be a bit more of a holistic representation of the business. That's your data lake, even if it's structured. So long as it's keeping history and when things have changed over time, I would call it a data lake. And yeah, sure, you can plug your BI tool directly into it, but as I mentioned, you might very quickly need to start building some more logic on top of it, and that's where it should live, in the data warehouse.
Awesome.
I hope that makes sense.
Another question is, do you recommend to do the historization in a storage service like S3 or Google Cloud Storage, or should it be also well done within a data warehouse service like BigQuery, Snowflake? What are the pros and cons here?
Awesome question. Obviously, if you have tons and tons and tons of data, it might help to put some into things like Glacier storage and so on. But in my experience, storing data in some of these big cloud data warehouses is cheap. Accessing it and doing compute on it is maybe a bit more expensive, but there's no harm done in storing it and kind of democratizing access to it quite easily. So you can allow your power users or your analysts or your data scientists to more easily, again, explore it and see what's out there, and then come up with requirements of what to actually push to the BI tool or to the data warehouse. So I would actually put it in the cloud data warehouse as soon as possible.
Awesome. Another question from Jose is, regarding data quality, would you do more a classic approach, TDD/BDD tests, or sanity checks on live data?
Yeah, I would do both if you can. I think when you're considering modern tools like dbt, for example, it's really nice to structure your data transformations in very atomic, step-by-step processes. This part does some cleaning, then this part does some integration, then this part does some preparation of a reporting table or whatever. And within each part, you can do testing, right? You can see, does this make sense? Do the calculations kind of constrain to some limits I have set out? And then sanity checks can kind of be done on larger tables, on kind of more realistic looking data. And I think as many checks you can think of, put them in, because you can never have too much data quality.
Awesome. So a huge thank you, Nas. I really appreciate this session, and so does everyone else.